Hi, we are InnoHackers. We hack with innovation. And here's our team. We have I'm Tanvir Ahmed. I'm the lead of this hackathon project and took care of the overall defining the solution itself. And Nayan, who took care of the development of the whole simulation. And we have Tansil, who took care of the debugging of the problems and issues we had. Zarif, who took care of the communication and testing. He took care of the analyzing the test results and identified the areas for improvement. Faisal, he's our ROI expert, and he took care of the ROI analysis and considering the labor cost and production uptime gains and maintenance cost. So here's we have the problem. The problem is we have a production robot that produces nest and which is highly profitable. But the problem is we need to select a proper transport option. And the transport option is to be such that we can maximize the ROI while keeping the feasibility of that solution and sustainability and scalability of the solution. At the same time, we need to increase the safety, efficiency, and profitability. Here's a debate we can see in the picture, and then we come up with a solution. So we propose a single AMR robot that works without predefined paths and it can charge during the idle times at an adaptive manner, and it can efficiently handle the transporting the nest from the production robot to the storage cell and bring the emptiness from storage cell to production robot. Our AMR solution is can future-proof for the testbed expansion. It's highly adaptable, meaning dynamic environment with obstacles it can work with. It doesn't require any layout changes. The single AMR with optimized charging method can continue to operation for 24/7 throughout the year. And we have shown that high uptime due to better battery life and faster speed. Now we can see our solution in action, and Zarif will take care of it.
Thanks, Tanvir. This is our working simulation in with one autonomous mobile robot in Emulate 3D. We are now looking at the digital twin of the deep test bed at UWM CSI, which fills vials in a highly automated fashion. The finished vials are moved back near the loading robot. We can see the yellow loading robot, and the robot places the filled vials into empty slots in nests where they are ready to be unloaded from the system. So after filling the nest, and the AMR robot will take care of it. We can see it from the video. From the video, you can see that the AMR in action, demonstrating how it navigates dynamically without predefined paths, adapts its charging during idle time, and efficiently handles the storage and retrieval of materials in a high-risk environment. So now AMR is waiting to unload. Then it will go into the charging position. For the simulation, it's taking a fixed time, but in real world, it can be adaptable, the charging solution. After charging certain amount of time, it will take up the empty vial tray and go back to the loading robot. So this demonstration emphasizes the AMR's capability to operate within the existing layout with minimal disruption and to ensure a robust return on a robust return on investment by enhancing safety, efficiency, and profitability in automated file handling and storage solutions. Now it unloads the file and it will wait a certain time and take up the new one and go back to the unloading dock again, and it will repeat the process automatically. So we can see from here that the AMR is taking the filled file tray and going back to the unloading dock. Now it's unloading. Then now it's waiting to take the empty nest and going back to the loading dock, going back to the loading robot. So our simulation works this way. So after this video, Amir, my fellow team member, will discuss about our ROI analysis.
Thank you, Zarif. That was a really cool simulation. I'm really glad that we came up with really innovative way to solve this issue, and that gives us a huge opportunity for producing more Nest and hence earning a lot of revenue. So we are earning more than 36 million dollars in yearly. That's a huge number. So if we look at the initial investment, so we have to rent the space. That's area investment. That should cost us 50,000. We will have to buy that robot, that AMR machine. So that will cost us 40,000, and charging station is 6,000. So there is obviously integration fees and fleet advisory solution. So our capital investment should be 121,800 dollars. There is an operating cost that we have to maintain each year. So that's listed in our annual cost sheet. That's annual storage maintenance, annual maintenance energy cost. We have to take financing. We have to pay an 8% APY. So our annual cost should be 14,544. So on the next slide, we can see that our ROI calculation for 10-year periods. So our rationale behind going for a longer period for ROI is that we can see how much revenue each year we are generating with really minimal annual operating cost. So that's why we thought, why not choose a longer period of ROI, and that then we can get a huge return on our initial investment. And you can see from this data, our ROI is more than 300,000, and payback period is really fast. And in fact, it's less than 2 days, 1.1 days. We also tried different combination and tried to calculate ROI for individual assets. For example, we choose one AGV and find out that the payback period is faster, and little the percentage change for ROI is little higher than us. Comparatively to our solution, human combination of human assets is give us more payback days. So the payback period is 3 days, and it's less efficient. So ROI is 61% less than us. Conveyance seems to be more efficient in terms of cost reduction. So we used 80 feet conveyor, two lift, and one bi-directional transformer. So the payback period is in fact less than a year, which is insane. You don't have to run your machine a full day and then you get payback with your capital investment. That's really huge. The percentage change is 25%, more than 25% than ours, which is comparatively really high return on investment. But there are certain reasons so why we didn't choose AGV and conveyance. So my teammate Tanzil will talk more about this issue.
Thank you, Amir. So from the previous slide, we saw that the ROI of conveyance and AGV are lower than AMR. We still choose to go with AMR because of certain limitation of those solutions. For example, conveyance has limited flexibility and requires significant space. It hinders access for maintenance and diagnostics and limits provision of collaborative environment. It also requires modifications on existing infrastructure. On the other hand, AGV requires predefined paths, which limits the adaptability. AGV is also less efficient due to its lower speed, and it's not ideal for dynamic environment. Finally, a human-based solution shows lower ROI due to its high recurrent costs. It has increased risk of injury and has higher costs for its scalability. On the other hand, our solution with one service AMR can serve more than one closely positioned deep units, doubling the ROI. It can accommodate workload even if the production rate of deep unit doubles. It maintains same ROI if planned storage area needs to be moved further away up to 2 times. In the event of predictive maintenance, a spare AMR can serve multiple deep units, keeping the ROI almost same. This ensures that our solution is scalable, sustainable, adaptable, and feasible. Thank you.